Have you ever stopped to think about how a truly massive smart building, we're talking tens of thousands of devices, can run perfectly without a single central computer calling all the shots? Well, we're about to dive into the absolutely fascinating engineering behind the KNX system that makes it all possible. Just picture it, a huge, modern skyscraper. You've got thousands of lights, HVAC systems, security sensors, automated blinds, all needing to talk to each other instantly and without fail. I mean, how do you even begin to manage that kind of complexity and make sure it's rock-solid reliable? Now, the obvious answer, right? You just get one super powerful central computer, a single brain to manage everything. But here's the thing, that's a huge design flaw. Because if that one controller goes down, the entire building can go dark. That single point of failure is a massive risk. We're talking no lights, no climate control, maybe even no security. Yikes. And this is exactly where KNX flips the script. Instead of putting all its eggs in one basket with a central brain, KNX distributes the intelligence. Every single device on the network has its own little microprocessor, its own tiny piece of the brain. This creates a network where no single component is the boss.
So how does that actually work in the real world? Well, it all starts with one fundamental concept: giving every single component its own unique identity. This is the bedrock that lets the system scale to incredible sizes.
65,536. Now that's not just some random number pulled out of a hat. That is the total number of unique addresses available in a KNX system, and it is the secret sauce to its massive scale. All of this is possible thanks to something called an individual address. Think of it like a unique postal address for every single switch, sensor, and actuator in the building. This 16-bit address means any device can talk directly to any other device, no middleman required.
And here's how that 16-bit address is broken down. Honestly, it's brilliant. It's just like sending a letter. The first 4 bits define the area. You can think of that as the city. The next 4 bits define the line. That's your street. And the last 8 bits, that's the specific device, the house number. It's such a simple and logical structure, and it's what allows for this incredible scale.
Okay, so now every device has its own unique address. Check. The next step is organizing all of them into a logical structure. This is how KNX literally builds the digital nervous system for an entire building.
The whole network is built in a really neat hierarchy. So, at the very base, you've got a line, which can have up to 256 devices on it. Then you can group up to 15 of those lines together into an area. And finally, you can link up to 15 of those areas to create a complete domain. It just builds on itself.
Take a look at this diagram. You can see how those individual lines of devices all connect to a main line using these special pieces of hardware called line couplers. This whole collection of lines, all tied together by couplers, forms one single organized area. All right, now let's zoom way out. This 3D view really shows you the big picture. You can see how you can stack multiple areas on top of each other. Each one of those areas connects to a high-speed central backbone, which is what allows the system to scale up to control, say, an entire university campus.
Now, we've mentioned these couplers that connect everything together, but they're so much more than just simple connectors. You should really think of them as the smart gatekeepers that prevent the whole network from descending into chaos.
Yeah, these couplers are like intelligent traffic cops. They literally inspect every single message that flies by and decide, okay, does this need to go to another line or another area? This filtering is what keeps the network incredibly fast and efficient. It stops unnecessary messages from creating a traffic jam, which means your commands happen instantly and the system never gets bogged down.
And there are 2 main types of these gatekeepers. A line coupler connects a line to the main line inside an area. A backbone coupler, on the other hand, handles the much bigger job of connecting an entire area to that central backbone. They each have a very specific job and a unique addressing rule to match. So how does the network tell them apart? Well, this is the really clever part. A coupler's device address is always set to 0. If its line address is also 0, boom, it's a backbone coupler. If the line address is anything else, it's a line coupler. This scheme is so brilliant because it hard-codes the device's role right into its identity. The network doesn't need some central map. It knows a device is a high-level router just by glancing at its address. Okay, let's put this all together. You've got unique addresses for every device, a clean hierarchy, and smart gatekeepers managing the traffic. With all this, KNX creates a system that can scale up to something enormous without ever needing a central master controller. It really boils down to these 4 pillars. First, decentralized intelligence in every single device. Second, that logical hierarchical structure. Third, a huge 16-bit address space for all that growth. And fourth, those smart couplers that manage the flow of information and keep everything stable.
And this brings us right back to that original problem we talked about. With no central brain, there's no single point of failure. If one device, or heck, even an entire line of devices goes down, the rest of the system just keeps on chugging. This means you get incredible resilience, less downtime, lower maintenance costs, and a level of reliability you can absolutely count on, especially in critical places like hospitals or data centers.
So this all leaves us with a much bigger question, doesn't it? As we keep building more and more connected systems, everything from smart cities to the Internet of Things, is this kind of decentralized thinking the real key to creating truly reliable technology for our future? It's definitely something worth thinking about.